Alright, so in section 3.6, oops, I see my recording toolbar is showing up. In 3.6 we're looking at logarithmic differentiation, and let me change the colors there. Logarithmic differentiation and the derivative of the log. Okay, so in this section we want to explore two things. One, what is the derivative of log base a of x, or more particularly the natural log of x? And two, can the log be used to help differentiate functions? Okay, so we're going to learn that the logarithm is very helpful in some situations it's absolutely necessary to use the logarithm before we can actually differentiate. So let's look at the first thing first, and let's see if we can figure out what the derivative of the log is. So derivative of the log. And the idea behind finding the derivative of the log is to use the relationship that we were talking about with the inverse trig functions between a function and its inverse. Okay, so therefore what I mean by that is we'll start like we did with the inverse sine function and the inverse cosine, and say, suppose I have y equals log base a of x. Okay, then I can rewrite that expression. That's the same expression as saying a to the y equals x, right? And now I can differentiate implicitly, right, by treating y as a function of x. And so do you remember the derivative of a to the x power? The derivative of a to the x is a to the x times the natural log of a. And so in this case we have a to the y natural log of a. That's the derivative of a to the x. But then we also have to multiply by the derivative of your inside function, right, by the chain rule. So dy over dx equals 1. Good. And so therefore dy over dx is equal to 1 divided by a to the y natural log of a. Alright, so when we got to this point, when we were dealing with the inverse trig functions, we had a triangle, right, to get rid of the y and introduce x. In this case, can I get rid of the y and use an x? I think we can if we go back to the original expression here. A to the y is equal to x, right? So therefore, this is equal to 1 over x natural log of a. Good. So therefore we now have our new formula. The derivative of log base a of x is 1 over x times the natural log of a. And that also gives us our formula for the derivative of the natural log of x. Right? That's going to be 1 over x times the natural log of e, and the natural log of e is 1, so that's just going to be 1 over x. Right? And so this is probably the most used, right? Although you can use the log base a. I guess it's good to remember this one, the more general case, right? Because then the logarithm, the natural log, just becomes a special case. Good. So let's go even farther, and let's see if we can figure out how would you differentiate d dx. How would you differentiate the natural log of f of x? Because that's really where how you get things presented to you. And so I can see the outside function here is the natural log, so the derivative is 1 over whatever is inside here, and so that would be f of x, right? And then you multiply by the derivative of what's inside, so that's f of x, so that's f prime. Good. So we get f prime of x divided by f of x. Good. So you don't want to memorize this formula, but just remember that you have to use the chain rule when you're looking at something like the natural log of f of x. So for example, how would you take the derivative of the natural log of 1 plus x squared? I'll give you a moment. Okay, did you say 1 over 1 plus x squared times 2x? Good, or you should just write it as a single fraction, but it's okay if you want to take a step to simplify. Very good. All right. Similarly, how would you, let's do one more example and then we'll go to the second question. How would you take the derivative of the natural log of the sine squared of x? So again, take a moment to think about it. Okay, so we take the derivative of the natural log first, 1 over something, and that something is the function that's here, and so that function will appear down here. Then you multiply by the derivative of that something. So in this case, the derivative of sine squared, remember the square, this is the same thing as taking the sine of x squared, right? So then the derivative is another chain rule. Derivative is 2 times the sine of x to the 1 power times the derivative of that inside function, so that's cosine of x. Good. So you end up with 2 sine x cosine x divided by sine squared. But of course you'd want to simplify a little bit, so that's 2 cosine of x over sine of x. Alright, and you can leave your answer in that form. Alright, so the second question that we're looking at is logarithmic differentiation. Or the idea behind it. And so the general idea is that you're going to be given something like y equals f of x. And the way logarithmic differentiation will work is we take the log of both sides. So you're going to take logarithm y equals natural log f of x. And then you differentiate. Okay, and so on the left, you see we're going to have 1 over y times y prime equals, and then on the right, you're going to have, well, whatever you're going to have. You would just differentiate this. I don't want to go too far because we're going to just end up back at y prime equals f of x. But this is kind of the process that we're going to use, and then we're going to solve for y after this. Or solve for y prime, sorry. And so let's see how this will work, why we would do this. And the reason why is something like this. Y equals x squared plus 3x plus 1 to the 4th power maybe times the square root of x plus 1 over x. Okay, and so the idea is if you have a big product or quotient, then the logarithm actually simplifies things quite a bit. Because if we take the logarithm before we differentiate, then remember the rules of logarithms. I can break this up into a sum, and also the powers come down front, and so this would be 4 times the natural log of x squared plus 3x plus 1 plus, and then this is a 1/2 power, 1/2 times the natural log of x plus 1 over x. Okay, and so I've taken the log of both sides, and now we differentiate using, so this side is using the chain rule, right? And then this side will have to use the chain rule, so 4 times, well, let's leave the numerator blank, x squared plus 3x plus 1 in the bottom, times the derivative, so that'll be the derivative on the top. Okay, 1/2, go ahead and rewrite that as x plus x to the minus 1 power. And so the derivative of that's going to be 1 over x plus x to the minus 1. And let's go ahead and save our numerator again. for 1 minus x to the minus 2 power. Good. And so then finally you would want to actually rewrite the y value here on both sides. X squared plus 3x plus 1 to the fourth times the square root of x plus 1 over x. And then you have this stuff over here that you would multiply. Okay, I'm running out of time, so that's why I kind of ran this short. So in the next video, we'll look at a couple more examples of logarithmic differentiation, and we'll see an example where we must use logarithmic differentiation. Alright, see you then.